3, 6, 9, 12, 16 problems. So usually it's somewhere around 8 or 9 or 10. This 16 is quite unusual, but they included a lot of relatively easy problems, which is good, which really helped you guys get at least get your feet wet and know what this competition is all about. So definitely congratulations to FIU Gold. I guess no one here from that team, right?
No, it doesn't look like it.
Doesn't look like it.
I'm here.
Oh, John's here?
John, hey.
Oh, John, yeah, John's here.
Oh, okay, I didn't see that. All right. Congratulations, John. That's pretty solid work you guys did.
Yeah, Ricky did most of the hard problems, really.
Well, in the end, that's what you do. You kind of break down the task into amongst you, and soon you guys will all have other areas of expertise, and I think by next time you should be able to take on more. We don't know if next year the style will be similar, but either way, that's pretty good. The competition is of course a bit insane, as somebody's just said, but our goal is so if you can do 3 to 5 with almost no training, I think you guys are probably ready to get at least 8 to 10 with some solid training. That is my guess. So our goal, it won't just be today, is to solve as many of these problems as possible, and in the process we'll also learn some new techniques. That's where we are planning to go. Okay. So as far as J, K, and M are concerned, looks like you guys are very comfortable with those problems. You're comfortable with your solutions. Even if you didn't solve it, I assume that you know how to solve this by now. Is there anybody who didn't do J, K, and M and who thinks that it might be worth our time here to go over them?
What problems specifically were J, K, and M?
J, K, and M were the ones that you guys first solved.
Okay.
I don't remember. Well, I do have it here. Let me show you. So J, K, and M are coming up. So J is magic trick.
Okay, yes.
Something about a card. I don't even remember now, but looks like you guys got it pretty easily. What was the problem? Yeah.
The step question.
Yeah. And then K is missing number. So you are given a permutation and you're told one number is missing and you have to figure out which one, right?
Yes.
Then there was this was what? This is K, and then not L but M. Okay. This is about a rating problem. I really like this problem. I don't even remember this, but anyways, looks like you remember this?
Yeah.
I didn't solve that question. I think Patrick was the one who solved this, but yeah,
you didn't read it either?
No, I didn't read it at the time. I was focused on
okay
problems.
All right. Well, so homework for you guys, at least J, K, and M. If you didn't solve any of those problems, go back. You know it's not hard. You know this is doable. So make sure that you can solve them. And if it's available on VJudge, then I can also put it on the Saturday mock competition so that you can submit a solution and convince yourself that you know how to solve it. Okay?
Okay.
All right. So let's look at some of the other problems that people found challenging. So I think, where did this go? So FIU Gold, that's not here. They solved this one, whatever that is, and I think the last one is P, This must be F. Is it F? Yeah, F. And I think several people asked for F and P to be discussed, so we could do this. Exam manipulation and unread messages. So let's start with exam manipulation. Yeah. So let's talk about this problem. This one says a group of students are taking a test. All the answers are true or false, and the teacher wants to make the class look as good as possible. So this teacher is willing to change the answer key so that the lowest score in the class is as high as possible. So he or she doesn't care about the highest score. He or she only cares about the lowest score. Okay. So you're given the scores, the answers of 5 students on 4 different questions. They're all true, false questions. And your job is to figure out what should the key be in order for the lowest score to be as high as possible. Is the problem clear to everyone, or does it need any more explanation?
It's clear, I think.
Yeah,
Okay.
it's clear.
All right, so let me hear from people saying what did you try and what didn't work.
I
Okay.
tried this question.
Okay, what did you do? What did you try?
Tried like creating like an answer key, kind of like getting the most out of each
So
column.
you could do a majority on each column,
Yes.
and that's what you did.
Yes.
Okay, and that didn't work.
No, it didn't.
So did you submit it?
I did.
Okay. All right, anybody else tried anything else?
I tried the exact same thing.
Okay. So do you guys understand why this could be wrong?
No.
Yeah, no.
Yeah, so the problem is that let's assume that so everyone has the same answer except the last one. Let's say for the sake of argument. Okay. So everyone, let's say, has either true or false, and the last guy has exactly the wrong answers for every question. So so think of this as true, false, 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 true, false. Whereas here you change it to false, true, false, true. So here, what would be the right answer? What should the key be in order for the lowest score to be high, to be as large as possible? Now, if you pick the maximum in each column, what would it be? It would simply be true, false, right?
Yes.
Because that's what the majority answered. But then the last guy would get 0. Right? That's terrible. And the teacher doesn't want that. So is it possible to make the bottom score to be 1 in order, in the process, others wouldn't do so well, but that's okay, because your goal is not to keep the bottom score as low as possible. Your goal is to keep the bottom score as high as possible.
Oh.
So what would you do?
Can we like break it up? And for every column, just flip it so the person all the way in the bottom, he gets it right, but everyone else gets it wrong.
So what if you made all the answers to be true? What would happen?
2 out of 4.
Yeah, 2 out of 4.
The bottom guy would get 2 out of 4, but what about the others?
2 out of 4.
Yeah.
Everyone would get 2 out of 4. So that means the bottom score now became a 2. And that's what you want. You want to maximize this. Does that make sense?
Yeah.
Yeah.
So now that you understand this differently, what would you do? So one thing we understood, taking the majority answer on each column was a bad idea, right? Clear?
Mhm.
So sometimes we have to take majority answer, sometimes we have to take the not majority answer, just in order to pump up the bottom of the class. Could I request you guys to turn on your video so that I could look at you?
Okay.
Since I'm not using slides, I can actually look at you. Thank you guys. So any new thoughts?
I was thinking maybe what if we can keep track of all the right answers? Like keep track how many, like assuming we take the majority elements, then we have like the lowest score and then see if we can kind of optimize that way. I don't know.
Well, in each case, there are only two possibilities. Either it's the majority answer or the minority answer, right?
Yes.
So it's not like that it's not like there are multiple choices. So it's not a multiple choice question. It's just a true false question. So that part is good. So for every one more thing we know is that if one of the questions, everyone has a true answer, what should we do with that?
Leave it as true.
So it should be true because there, no one's going to mess up. So we might as well keep it as true and we're in good shape. So all columns where everyone has the perfect answer, we can throw that out. Okay. So let's assume that we are now only focused on things that are where they don't all agree. Now in this, so that means at least the first two columns are true and false. That's the majority. Everyone seems to have the same answer. So we're going to get those two correct anyways. We don't have to worry about this. Okay. So we only have to worry about columns 3 and 4. And in general, we are only going to worry about columns where not everyone has the same answer. Now we are left with these two columns. What should I do? Any thoughts?
Maybe do like a breadth first search of all like the possibilities of choosing true and false for each of those two columns.
Okay. So you're suggesting something like an exhaustive search, right?
Yes.
Now, how do you know this is not going to go crazy and we can actually the program would actually run in reasonable time? How does one think about this?
You have to look at the size of n.
That's right.
Yeah.
Yeah. So we have to look at the number of possibilities and estimate the time, the number of different operations that we'd have to perform on this, right?
Yes.
Okay, so let's look at the problem again then. We are told that there are n people, right? Where n is the number of students. So that means that there are n rows, right? So these are, n is equal to 5 here. And then we are told that k is the number of columns, or it's the number of tests. So we have 5 rows and 4 columns. That's what your data set looks like. Now, since there are 4 possible questions here, or k possible questions, how many different combinations do we have to deal with?
2. Wait, 2 factorial?
If there are k questions, if there are k true false questions, how many different combinations do we have to take into account?
2 to the k.
2 to the k, very good. So we know there are going to be 2 to the k possibilities. Now, each one is a possible answer. right? Each one it's possible gives you the best, maximizes the lowest possible score, but we don't know which one. Could we try all of them? Now, in order to try all of them, we have to figure out how much time this will take. So first of all, we know that there are 2 to the k different possible answer keys, right? Now, for each one of those, what is the work that we have to do? So let's pick one of those answer keys. So let's say we're going to try true, 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 true. All k values are true. Now, for that, what is the work that I have to do?
Evaluate it to the kind of the possibility.
We go through each student, figure out what their score is going to be with that key, and pick the smallest, right? So is that pretty easy to do? Right?
Yeah.
Okay. So for each of the 2 to the k combinations, we're going to look through n times k values and keep track of some counts. So the total amount of work that we have to do is 2 to the k times n times k. Is that clear?
Yes.
How much is that?
2 to the power of 10, worst case.
Right? That's about 1,000.
1,000.
2 to the 3, n is another 1,000, so that's 10 to the 6, and another k, that's 10, so 10 to the power 7.
Yes.
So that's like 10 million. That's nothing. So all we have to do is write a program where we generate all possible true, false answer keys, right? And then for each one of these, we go and run it through the sample input, find the lowest score, and then keep track of the best so far.
How do you know if an input size is nothing or too much?
Good. So so that's something we have to worry about. We know what the time limit is. What's the time limit?
1
That's
second.
1 second. Now, how many operations roughly can you do in 1 second?
I forgot.
Well, remember, these are gigahertz machines, right?
So 1 million?
What's gigahertz?
1 million. 10 to the 6 is giga, right?
No, that's mega.
Oh, 10 to the 9th? Is
Yes.
it? So a billion.
So roughly you can do 1 billion operations per second. Okay. And here we're talking about 10 million. So, and secondly, you can probably throw away some of the columns where all of these are equal. Okay. So I would bet some money that if you just generate all possible combinations and tried this, it would work out fine. I haven't tried this, but that's what my money would be on.
Okay.
Okay, so you have to do some mental math in order to figure out whether that's feasible or not. So it's very easy to remember that 2 to the 10 is 1024. So just think of that as 1,000. 2 to the 20 is how much?
Is it 1 million?
Yeah, it's 1,000 times 1,000. That's about 10 to the 6. That's 1 million.
Yeah.
Okay, so these are easy ways to remember. Fine?
Fine.
Okay. So you do some quick mental math to figure this out. And the code to write is really quite simple. By the way, how do you generate all possible combinations of answer keys?
Recursively.
Yeah.
You know how to do
Backtracking.
this? You guys know how to do this?
Yeah.
Yeah.
Okay, all right, cool. Okay, then Saturday you can have it done, right? For
Yes.
if I give it to you for this for the competition.
Yeah.
Yeah? Okay, good. Now are we ready to move on to the next problem? Are you okay with this? Very good. Adriana, all good?
I'm alright with it. Uh, um, mm, yeah, I'm fine.
Okay. All right, so let's talk about P. Now, this one is a little more complicated than the previous one. Who hasn't read the problem? All of you have read this?
I
Okay,
haven't read it.
read it now. So this one says, there's a group of people who are on an internet email message group. Messages are sent to all members of the group, and no two messages are sent at the same time. Before a person sends a message, this person reads all their unread messages up to that point. And reading the messages, we're going to assume, doesn't take any time. Each sender also reads their own message the moment it is sent. So you don't have to worry about that as being a unread message. And then, so the unread messages for any person is exactly the set of messages that were sent right after that person's last message. Okay? And your job is to figure out how many unread messages there are in that entire group. So let's do some example here. We are told that the input has n, which is the number of people in the group. So in this example, there are only 2 people in the group. And you're also given the number m, which is the number of messages sent. So there were 4 messages sent. And the next 4 lines here tells you who sent the message. So there are only 2 people in the group. 4 messages were sent. The first message was sent by number 1. Second message was sent by number 2. Third message was again sent by number 1. And fourth message was again sent by number 2. Now let's take a look at what's going to happen. Remember that people read their messages only when they want to send something. Until then, they don't look at anything. Okay. Now, when person number 1 sends a message, this person will send it to, essentially, since there are only 2 people, this message will go to number 2 because number 1 has already read his or her own message. So number 2, that message will sit in his or her mailbox and will not get read until he or she is ready to send something. So after this first message, there's going to be 1 message that's going to be sitting in number 2's mailbox, right? Then number 2 sends a message, which means that by that time, number 2 would have read that unread message, but he would have also read his own message and would have sent this over to number 1. And that message is going to sit in number 1's mailbox, and she is not going to read it until she sends another message. So that's why there's 1 unread message that's sitting at the end of step number 2. Then in step number 3, again, number 1 is sending a message. And in this case, it goes to number 2. So it's going to sit in number 2's mailbox. And so that one is going to be unread. And then there's number 2 sends it. So this time there'll be 1 message left in number 1's mailbox. By the way, can you think of a scenario where this number might go above 1?
When there's more than 2 people.
Well, what if there's only 2 people?
Maybe person number 1 sends a lot of messages and number 2 hasn't recorded any.
Sorry, can't hear you. You're a little muffled. Can you repeat that?
Well, hopefully it's better. Only if person number 1 sends a lot of emails. And
Right.
number 2
So if 1 sends all these messages, not 2, then what would happen? After 1 sends the first message, it's going to sit in number 2's mailbox. So number 2 has 100 message. If 1 were to send another message, that 2 is going to sit in number 2's mailbox. And so number 2 would have 2 messages that are unread. When person 1 sends another message, same thing is going to happen. So at the end of 4 messages, there are going to be 4 messages sitting in 2's mailbox, all 4 of which are unread. Okay. Now, of course, if there are more than 2 people, things get a lot more interesting. So the question is, how are we going to figure out how many unread messages there are? Okay. Now, this one is a little tricky, but it turns out that you can do this using a lot of the things you already learned, which would be red-black trees and augmented red-black trees and balanced red-black trees. So let's see how we're going to do that. Okay. All right. So what's going to be the scenario at any given time? At any given time, there are n people, and each one in their mailbox has either 0 or more messages that are unread. Okay. So let's assume that we have that information for every person in the group. So we know that person number 1 has some number of messages unread, number 2 has some number of messages unread, and so on and so forth. Now, what will happen in the next round, next time instant? What happens in the next time instant is that one of the people in this group decides to send a message. In order to send that message, he or she first has to read all his or her unread messages, and then sends one to everybody. And those messages sit in their mailbox unread until something else happens later on. Is this clear? So this is the scenario you have. So it's important to know who has how many unread messages at any given time. So let's say there are 4 people. Okay, and you can assume whatever number of messages unread in all these mailboxes. Doesn't matter. So so person number 1 has some number of messages left unread. Person 2 has some number of messages unread. Person 3 has some number of unread messages, and 4 has some number of unread messages. Now let's assume that the next message is sent by person number 3. And let's say that person number 3 had 6 unread messages. Now, what's going to happen in the next time instant? Before person number 3 sends any messages, he or she is going to read those 6 messages, which means that the number of unread messages will go down by 6, right? And then she is going to send one to everyone else. So what is going to happen to the unread messages of the others?
They will increment by 1.
It's going to increment by 1 for each one of them, right? So you add 1 to everybody else's mailbox of unread messages, and you decrease number 3's count by whatever was the number of unread messages he or she had at the start. Is that clear? So that's what you have to do in each step. That's how you simulate the whole thing, right? So now the question is what? What is the question? The question is how many you're supposed to compute the total number of unread messages over all group members at the end of each step, right? So you have to kind of keep track of this. So for now, let's ignore the number of, let's find the simplest solution. Let's not worry about fancy red-black trees and efficient algorithms. What is the simplest solution we need to find? Well, it's very simple. You have n people. You make an array of n items. you start with the number of unread messages for each one to be 0. You keep an extra count of the total of all the unread messages, make that 0, right? And then start to read the input. The input says the first message was sent by somebody, let's say number 3. You're going to make sure that 3 becomes 0 and all the others are incremented by 1. So with order n operations, I can take care of one step, right? And how many such steps are there? We know that there are m such messages. So m times n is what I'm going to need in order to figure out what happens at the end of every step. All this clear? So given the numbers m and n over there, how much time will this take us? So you're told that n is 10 to the 9 and m is 10 to the 3.
10
So
to the
that total is 10 to the 12, right? Now, question is, sorry?
Sorry, I said 10 to the 10 at first, but you said 10 to the 12, sorry.
Yeah, it's 9 and 3, right?
Yeah.
You're clear. But the time limit is 1 second. 10 to the 12 is a trillion. And it's unlikely your program is going to finish by then. Okay? So we have to come up with some new tricks in order to make this happen. So this much you should be able to do quickly before you try to think of fancier solutions. Okay? So think of the easiest solution first, make sure it's clear in your head, then start to think of fancier stuff. All right, are we okay with this so far? Okay, so now how do I come up with fancier ideas? Any thoughts on this?
Red and black tree.
Yeah, well, that I already told you, red black trees are what's needed, but that doesn't help me.
Well, I think it's important to have like an idea of how many unread messages each person has, right? Because when someone reads once you send a message, we have to decrease the number of the messages they haven't read. So I guess that's important. We need to store maybe that information some way, or without an array, which is like takes a lot of time and the memory.
Right. Still unclear what to do.
Well, since we know that big O of n doesn't work, we know that we have to go somewhere lower, like big O of log n. Then from there, we can look at our data structures and try to find what can work.
Mm-hmm. Right. So here's a possibility. Again, I'm going to give you a simpler solution, which doesn't work in terms of efficiency, but maybe it'll give you some better ideas. Now, in the first idea, what we said was that we're going to keep track of the number of unread messages for all people. Okay, and then we're going to reduce it to 0 for the one who's sending the next message, and we're going to increment by 1 for all the others. Right? That's what we want to do. So instead, let me do something slightly different. Instead of keeping track of all the n people and their unread messages, let me keep those numbers in sorted order. Okay. Now, so the main problem that we have is the problem of incrementing by 1 for everyone. Incrementing by 1 for 10 to the 9 people is just nuts. That's crazy. That'll just kill our program. So if we don't have to increment by 1 for every guy, for every message that we send, then we might be able to do something, right? We might be able to figure out a faster solution. So how do I avoid having to go and increment everybody's number of unread messages by 1, but still keep track of a total? Well, that's actually easy, because for every message I sent, every message that anybody sends, I know that the number of unread messages are going to be n-1. And the number of messages that will actually get read are simply the number of messages for that person. So I could just keep track of a sum total instead of having to figure out how much each one has unread, right? So we're going to step away a little bit from keeping track of everyone's unread message count and simply keep track of a total. Now that sounds great, because we can, all we have to do is to increase it by n-1 for every question, for every message. But the problem there is now I don't know how much to reduce it by, because I don't know the count of one person. So let's focus now on how to compute the number of unread messages for some person at any given time. Can we do that quickly? That's the question.
Can we store the value in the red-black tree, the number of unread messages across a range?
Well, don't go to red-black trees yet, John. That would be my suggestion. I should not have mentioned that. Let's come to that a little bit later. For now, let's just think about this in a simpler manner. You'll see that maybe at this point, even I'm not 100% convinced we need red-black trees. So let's follow this thought process. Okay.
Okay.
There may be an easier way. So I'm still trying to figure this out. So for each person, I need to figure out how many unread messages there are. How do I do this? Yes, Adriana.
Wouldn't we be able to find out by dividing by m the amount of messages? Or am I?
Yeah, that doesn't make it. No, that's not going to work.
No, like n-1 divided by m. That's what I meant.
That's just an average. It makes individuals are going to have different number of messages sitting in their mailbox.
Okay.
All right, so back to the question. We're asking for any person at any given time, how do I figure out quickly how many messages are sitting in their mailbox?
Wait, for any one person?
Yeah.
Oh, isn't that from the last time we saw that person to now and every message in between?
That's right. So all I have to do is to keep track of when they sent their last message. So I am going to simply keep track of, instead of keeping track of unread messages, I'm only going to keep track of when each person sent their last message. And I'm going to keep track of a total of unread messages. So these are the only two things I'm going to keep track of. One is an array where for each person, I will keep track of when their last message was sent. And another one that's a sum total of all unread messages. So now, in fact, I don't need red-black trees, it turns out. I can do this much simpler. Do you guys see this already? I see John shaking his head. You want to help me?
Yeah, we can just like use the index as like to index the people of the array, and then the actual values like when they sent their last message. So we can just iterate over like the entire input to.
Right. So now what about the initial values for this for when the last message was sent?
The initial values,
Yeah,
isn't it 0?
good. So initialize it to 0. Okay, and then for every message that's sent, so let's say we are at the ith request. The ith message, let's say, was sent by person number J. What we would do is we would go to the jth person and find out when they sent their last message. It might either be 0 or it might be something else. We find the difference between I and whatever is that number stored over there. That'll tell us how many messages were sent between those 2 time points, right? And that's the number of messages that are sitting in his or her mailbox, unread. So we decrease the number of unread messages by that number and increase it by n minus 1. And we're done.
Professor.
And we have to also make sure we change the last message sent of person number J to be I. Is that clear?
Can
Yes,
we
Liz.
So I tried to do something like this, but instead of array, I used a hash map to store their last value. But an issue I came across is if I stored the initial value as 0, if the messages was 112, and me first time seeing that too will be an index.
You're right. So there is a problem, because if somebody never sends a message, then you end up with a problem, right? Yeah. So you're absolutely right. So I didn't take care of that case. So what you should do is initialize everything to -infinity. Okay. Now, when you try to figure out the difference between the number stored there and your current time, if that number is -infinity, then assume that it's 0 and make the difference, but change it then immediately. Until then, it's going to stay as -infinity. All right. And then at the end, when you add up the number of unread messages, oh yeah, how do you take care of things at the end? So you have to do a difference between the last time point and whatever number is stored there for each of the guys. So what's wrong with that? That still works, Lazaro. Why didn't it work for you?
Wait,
Even
what,
if I had 0, it would still work. So tell me your problem situation again.
yeah, the issue was if it was like 112, if I had it set as 0 and then 2 was at a position index 2,
Yeah.
it would say that there was 2 messages there. Oh wait,
No, doesn't make sense. Maybe you didn't reset it to 0 for number 2.
yeah, okay, that might have been it.
Yeah. Yeah, it may be just a minor bug. I think you may have had it already.
Is there a way that you can write these steps out, like, and send it to us, like, after the lecture?
I want you to do it. You just had the whole thing.
I feel like I'm gonna forget.
Let's do it now.
Okay. Yeah, let me.
Here's a whiteboard. Okay. So let's say I have the array A, which has n items, right? They're all initialized to. What do I initialize this to?
0.
0. Okay, so I'm just going to put a 0 here.
Oh, wait, I have another question.
Yeah.
Since those n items, for example, in the second example they showed on the PDF, it had the numbers like 1, 2, 3, and then 9. So instead of having an array, would it be better a hash map? Because if it was an array, it would have to be filled with zeros until it had the min and max.
Yeah, you're probably right, because it's 10 to the 9. Yeah, sure. You're absolutely right. But then when you go back and add things up, you have to make sure that you add them up for every person. And you have to initialize this at some point anyways. So I'm not sure what you're going to do about initialization in a hash map.
We can go over it twice now. Yes, have those unread messages.
But if you're going to do it twice, then I might as well store it in an array. Am I not allowed to have an array of size 10 to the 9?
No, you're allowed, but I was just thinking of space.
The array will use less space than a hash map, because none of these are not going to be used. You're still going to go and look whether you used it or not.
So every index inside of this array, what does it represent? It represents n.
Right. So every entry here represents the last time this person sent a message. So this is person number J.
Mm-hmm.
We want to know when was the last time this person sent a message. And to start with, none of them have sent a message, so they're initialized to 0.
So and then J, for example, if we were looking at the problem we're just looking at.
Yeah, but I'm getting to it. Yeah.
Okay.
So
okay.
this is the last time, last message sent. I can barely write with this. Yeah. All right. And I also need a sum total. So let's just call this S. Now, my code is going to do, so by the way, how many, so I know that there are n people and n messages, right? Yeah, n people and n messages. Okay, good. So what happens now? So I'm not going to worry about initialization. So I go and initialize everything to 0, right? I initialize my sum total to 0. And I'm going to first read n and m and get those into some variables. I won't worry about those either. Now I'm going to do for I equals 1 to m. Right? So I'm looking at m of these messages sent. For each message, we figure out who sent the message. Okay, so let's say J equals sender of, so this is the sender, right? Sender of message I. Is that clear? Okay. What do I have to do next? So I'm going to change, I'm going to adapt, I'm going to modify S to be help me.
Isn't it m of I minus, wait, no, m of J minus m of I? Or,
Nope.
Sorry,
Yeah, go ahead.
I'm just confused. S is in time where the last message was sent? Or, yeah, sorry.
S is our final answer. It's the sum total of all unread messages.
Okay, okay.
Number of unread messages.
oh, it's S plus J.
S plus.
J.
What is J? J is the name of a person.
Or M of J.
Sorry?
M of J, which is the last message sent.
Our array is called A. I don't know where you got the M from.
Oh, A of J. Sorry, I thought the array was called M.
No. I'm just saying this is message at time I.
Oh, okay, okay.
Okay. So M is what you read in. So M is the sender at time I. So this is the sender list.
Okay.
Okay. All clear?
Yes.
Okay. So what did you decide? S plus what?
N minus 1, right? Because
S plus A of J.
Not quite. Is it? Does it get increased by A of J or decreased?
decrease
Oh, decrease because
decreased.
it's the last
Right.
sentence.
So what else? How much
N
does it increase by?
N minus 1, right? Because there's a number of messages.
Very good. Yeah. So it's S plus N minus 1 minus
Minus A of J.
Very good.
Mhm.
Yeah. Okay, we're done. That's pretty much the code. Now, what do I have to report at the end?
S.
Is it just S? No, so you have to be, yeah, it's just S. You're right. Okay, cool. So whatever, print S. You still want me to send you this?
No, no, no. That's good.
Okay.
It's just setting the value of S is what confused me without seeing it in like step by step. Yeah.
Yeah,
But
I have to initialize S to 0.
okay, okay.
Anyone see any problems with this? Oh, I forgot to change A. This is wrong. Guys, you guys didn't tell me.
Yeah.
So somewhere here, I have to add in some more stuff. Yeah,
Yeah.
tell me what.
We need to change the time that person last message was sent, right?
Yeah, tell me exactly what to say.
So A of J will be equal to I, I think.
Very good, perfect.
Oh, okay.
Oh, sorry. I'm losing control of my pencil here. A of J is equal to I. Right? Super. I don't think you need anything else. I think that's all you need. You have to write some initialization code. So I'm not going to write that for you.
Professor, the S is equal to S plus N minus 1 minus A of J. That also, it adds up all the unread messages of everyone else.
I don't. Good question. Yeah, it does. Sure. So we initialized S to 0, right?
Mm-hmm.
So to start with, nobody had any messages. The first message that was sent, it's going to sit in everyone else's mailboxes. So that's going to be N minus 1, and A sub whoever that first person was 0. So to start with, you're going to add N minus 1 to everything, and then this is going to get changed as per this for loop. Perfectly fine. Yeah, I don't see anything wrong. I could be wrong, but it looks okay to me. Aren't you amazed how easy it turned out to be? And I was wrong. I thought it needed red black trees.
So yeah. I think, well, because I didn't try, one of my teammates tried and he went into a memory limit. So that's why I was trying not to use like an array, but maybe he, because his logic was kind of different. So I will see.
Well, what is different here is to think of the array not to keep track of the number of unread messages, but to keep track of when the last message was sent. That's the key.
Oh, okay. Yeah, that was clear.
Okay. So we are simply keeping track of when that last message was sent. And of course, this you're going to need anyways, because you have to compute it at the end, the S. The rest is just what came from the input, right? This is just the sender list from the input. As you read stuff, you're going to process it. So here I need a statement that says read in the next input and put it in M sub I. I don't even need to store it actually.
Wait, Professor. So if we were to run this with sample input number 1, so the first one is sent by the person 1.
Okay,
S,
so let's do that. So my A is going to look like 0 and 0, right? And I'm going to have S to be 0. That's what I'll start with, right? And then I have one will send a message.
Yes.
And at that point, what will happen is that this will become 1, right? And this will become 1, because n minus 1 would be 1, and the difference between and A sub j would have been reset to I.
And now in the next iteration, when 2 sends a message, S becomes 2, no?
So when 2 sends a message, S will become the total of unread messages, because you have to first reduce it by this. Sorry, you add 1 to it, but then you have to subtract this much, and that you're going to subtract the 1. So add 1, subtract 1, and it'll still remain as 1.
But isn't 2 0? Why is it 1?
Okay, so you're doing S gets S, which is 1. So let me change the color of this so that we read something else. So S was 1 to start with, right? This is 2. And A sub 1 is 1.
Okay.
Sorry, A sub, A sub 2 is 0. Oh,
0,
right.
yeah. When one sends a message, don't you have to? Oh, never mind.
Sorry, this is A sub j, not A sub I. So it's the A of the sender. Oh no, I got that right. Oh, so we forgot. This is actually a mistake. Sorry. Yeah, this is actually wrong. You want to subtract out the number of unread messages for sender J, and the number of unread messages is actually I minus A sub j plus 1, or is it minus 1? Minus 1. This is the number of unread messages for person J.
Yeah, that's right, because we're
So,
taking, the time.
you're talking about time I. The last time J sent a message was A sub j. the difference between them is I minus A sub j, and you have to subtract 1 because you shouldn't count the last time, right? So if you now apply this, what will happen? I'll get 1 plus 2 minus 1 minus, for 2 it'll be 2 minus 0 minus 1. So you'll get another minus 1 here, not 0. So now you get f still remains as 1. Then if you look at I equals 3, which would be the third request, when you look at the third request, this would still be 1, this would still be 2, this would still be 1. And then this guy here is going to be 3 minus A of 2, which the last time it sent was in 2, minus 1. So that's going to be, bring the whole sum back to 1. Is that clear?
Mm. Okay.
Yeah, so sorry, that was a mistake. This is the right version, I think. Okay. Oh. We are almost out of time, but we at least solved the 2 problems that I got requests for. Any other suggestions for something we won't be able to solve a new problem, but if you want to think about one other problem, I'm happy to spend 5 or 10 minutes to do that.
There was a very interesting one, but I don't think they have it because that was for the practice. I think, John, right? You were asking me about that one, the singing test. No?
Your microphone is very muffled. I can't hear you, Samara.
Oh, okay, sorry. I don't know what's happening.
If you want to type that in, maybe we could talk about it. So I think somebody asked for, was it? Somebody asked for either A or E. I'm not sure which one.
A is the knapsack one, right?
No, A is the ant one. I think B is the knapsack.
Oh, yeah. The ant one was hard, actually.
Yeah. So for the ant one, so you're told that this ant has to walk around, walk on a configurable keyboard, and you want to minimize the total walk for the ant, right?
Yes.
And you're given a certain number, and you're allowed to reshuffle the digits in order to minimize the walk. Now, one thing that's obvious here is that, well, let's look for simple solutions first. Let's not try to be super smart. What is the simple solution? The simple solution is try all possible permutations of the keyboard, right? And for each such permutation, figure out how much the ant would have to walk. That's one possible approach. Now, in order to do that, how big is that problem going to be? So,
oh, sorry.
Go for it.
2 to the power of n, however long the keyboard is.
Right. Well, no, in this case, it's only 1 through 9, right?
Oh. Yeah,
so 2 it's only 9 keys. So are you saying it's 2 to the 9?
Yes. Or is it 9 to the power of?
Remember, these are permutations, not combinations.
Oh, okay.
Is it 9 factorial?
It's 9 factorial, yeah. So 9 factorial, it turns out it's not that much bigger than 2 to the 10. I think it's somewhere in the range of 500,000.
Yeah, 362,000.
Yeah, somewhere around there. So for each of those 362,000 cases, you have to go through the string, figure out how much the ant has to walk, and find the one that's the least. Okay, so this is the naive solution. Now, is this even doable? So 300,000 is 3 times 10 to the 5, right? And this is roughly, you're told that the string is 10 to the 5. So therefore, your total time is going to be 3 times 10 to the 10. Right?
Yes.
This is doable as far as I can tell. But you would have to try to figure out whether it crosses the time limit or not. I don't know. There is a smarter way to try this, but this is what I would try first. It seems borderline, and I don't see a problem with this. The one problem is to generate the possible permutations. And that sometimes takes a little bit longer than just n factorial. And it might make a difference whether you have this in, so I don't know. I don't know whether this simple version will be done in time limit 1 or not. There are other ways to do it, and I'm happy to discuss that, but this is what I would try first.
Would oh, sorry.
Right.
Yes, did anybody try this?
Yeah, I tried it, but the way I tried it is, given our input, why can't we start off the ant with the first number of the input?
Yeah.
And then in the next key be the next number.
Yeah, well, that's not going to do very well because you don't know how long the string is, and the patterns that you see later on might be very different from this initial part of the string.
Mm-hmm.
So the initial part of the string might completely mislead you. So there is no reason to think that that's something that's important.
Okay.
Instead, the approach that, by the way, if this simple naive strategy of trying all permutations doesn't work, then you could keep track of how many times any number is followed by some other number. Okay, so you can keep track of how many times 1 is followed by 2, or how many times 1 is followed by 3, 1 is followed by 4, etc., etc. So if you make a little matrix that says for every pair of numbers, how many times something is followed by something else, then it'll tell you which one you want to keep close to each other. Does that make sense? So for instance, in this example here, well, here nothing is repeated, so it really doesn't matter how. Sorry, there is a.
We can't see the problem on the screen, by the way.
Oh, you can't. Sorry. Yeah. Let me think about this some more and see if I can come up with a better solution than what I have right now in my head. But I'd strongly recommend trying the simple naive method of just trying all permutations. Okay?
Okay.
Any questions? Clement, Adriana?
No, Professor.
As far as the naive solution goes, no.
Okay. All right, why don't we continue later? I'm going to give you these 3 problems for your mock competition and add some more, okay? Let's hope that I can find these problems on VJudge. If not, I'm not sure how I could assign them to you. If not, I recommend that you guys try these and make that your mock competition for Saturday, okay?
Okay.
They should be available on Catus. So
Yeah.
you should be able to submit this. So there should be no problem. So I'll definitely assign you these 3 as your first 3, and we'll take it from there.
Okay.
Okay.
Sounds good.
All right.
Thank you, Professor.
Okay, guys. Have fun.
Bye.
Thank you.
And once again, congratulations on your excellent performance.
Thank you.